something. What is it? You know, we have X, we have X1, X2, these are the features, and then we have Y, this is the target, the output. Usually, I usually favor normalizing this value. I don't usually normalize this, but you can normalize this. But if you normalize it, but you must remember to denormalize the output. Because let's say a value is like 200, 2000. When you normalize it, maybe to between 0 and 1, everything will come between 0 and 1. The maximum will be 1, 0 point something, 0 point, even 2000. So when you predict, your prediction will be low, will be small values. But you have to use the opposite of the normalization formula to return your prediction back to the original value. Because we want the original value in the final result. This has to be noted. If somebody wants to use normalization, usually I ask my student to avoid normalizing the output. But sometimes, if the output is really tough, the system may not be able to model it. But remember, if you normalize output, you must denormalize the final result, because the actual value, imagine somebody predicting salary of someone, you want to predict the salary of someone, and you are saying the salary is 0.3. 0.3. How can somebody's salary be 0.3? Because you already normalize 2,000 or 50,000 to between 0 and 1. Normalization has the advantage that the data will be a little bit focused on, for example, a normalization of between 0 and 1. Even if you have 10 billion, that 10 billion will be converted to 0 and 1, between 0 and 1. So imagine that when you now predict, and you are predicting 0.01, you have to use the formula to denormalize it back to the original value. Maybe then you're going to have like a 1 million as the prediction you are making. This is a point of note I want us to take note. Once you normalize your output, then you have to remember to denormalize before you check your final performance measures and before you plot. Otherwise, you'll be plotting a wrong value that once somebody look at it, say, no, this is not a reality. You are modeling billions of numbers. Now your result is 0 point something. They will not, oh, this is the result of normalization. You have to bring it back. But if you normalize only the input values, input variables, you don't need to denormalize them because you don't need them again. Just you are getting your best result. You are getting your best result. Then that is fine. So this is a clarification I have to make on this issue of normalization. Sometimes it works, and sometimes normalization may not produce better result. But the idea of assuming that all data sets must be normalized before usage is not real in the principle of machine learning, especially if you really want the data to speak. The original data may be the best bet for our algorithm to model, sometimes the normalized one. So we have to check and have all these optional results on the table, and then we can compare. Last but not the least on that question regarding iris, once you are working on images, sometimes the array is already converted to number, that's fine. But if you want, one of the advantages of deep learning is you can use deep learning to automatically extract features from images. And that's one of the strong points of deep learning. So once you extract the feature automatically using deep learning, you can use the deep learning also to train and test. However, I encourage that someone use what I call hybrid model. The hybrid is you use deep learning to extract the feature. That feature you have extracted using deep learning, now pass it to ordinary standard machine learning algorithm like k-nearest neighbor, like decision tree, like support vector machine. Use deep learning also to model it and compare the result. You'll be surprised that sometimes the ordinary machine learning algorithm performance may be better than that of deep learning in the final analysis. However, deep learning has something that ordinary machine learning model doesn't have, and that is the opportunity, the capability to automatically extract the features. So we can take advantage of that by letting it extract and compare the one that human being also extract. There are a lot of feature extraction techniques that human being can use, softwares, but can we compare? It's one of the very interesting research on such a topic. Can we compare the automatically extracted features by deep learning with those one extracted using other software that we run as human beings? Do we have differences in the performance? These are some of the areas that we can also beam the searchlight as the research progresses. So thank you very much for the question. And I think we're going to have one or two more questions here.
Thank you, Prof. Thank you, sir.
You're welcome. Thank you.
Yes, sir.
Yeah, there's a question here that can normalization be reversed? Yes, well, you have your original data, you normalize the data, and then you want to undo it. Yeah, you undo it. So usually you can normalize your data yourself in the Excel file. It's a simple formula. We already discussed normalization. We can check out some of our videos. We can search our YouTube channel, normalization. You see some of the explanation there. We have different types of normalization. You see the formula you can put in the Excel. You can also use software to do that. So, but remember, your original data should always be with you. In case something goes wrong, you can always revert back to your original data. Yeah. So when you upload it to Weka, whatever you do, undo, it's only being done in the package. It's not affecting your Excel file where you brought in the data from. Once you brought the data in, the Excel file is not touched. All the manipulations will be taking place in this system, in memory. So another one says, okay, Assalamu alaikum. I am a chemist who work with environmental samples and pharmaceutical analysis. Can I apply my ML to my physical-chemical parameter generated from the study? And I make prediction? For sure, yes, you can do that. This is one of the very interesting areas you can use machine learning for. Once you have your data, put it in form of Excel file, like I show you today. Column 1, X1, the parameter 1, parameter 2, parameter 3. What do you want to predict? What do you want to determine? You have X1, X2, X3, Xn, then the Y is the target. Once you have your data, machine learning can be used. So it can definitely be used. It's possible. And can also improve some of your service delivery and facilitate better decision making. Some of those parameters are pH, conductivity, salinity, acidity, organic content, hydrocarbon content, and so on. How do I combine these values together using ML modeling and prediction? Yeah, it's very easy. Just put them in an Excel file, and then you can, if you join the platform, if you are new, so there's this regularly posting for new members. There are 4 videos, introduction to machine learning. The next video, another 3, making 7, how to build your first model in Weka. Once you watch these 7 videos, God's willing, you are going to be able to run your first model. And if you need further follow-up and maybe consultation, feel free to reach out to us. We'll see how far we can help you. But put your data in Excel file, column 1, column 2, column 3, and the target. Save it as CSV, you are ready to go. But if you are new, I recommend that you watch those 7 videos. At least by then you watch the first 2 introduction to machine learning and the first video in the Weka series, practical demonstration. You should be able to start. We have seen people who actually successfully did this, and I believe you can also do it. But if you have any feedback or consultation to make, you're always welcome to contact us. We'll be more than happy to help you out. So I believe those are the questions we have for the day. Once again, thank you all for listening and wish us all the best. Thank you very much, and bye for now.